In some algebra problems, it may be more convenient to work with decimals as opposed to working with fractions. So in this video here, let's talk about how we take a fraction and we write that fraction as a decimal. So if you have a fraction, what you're going to do to turn it into a decimal is use something called long division. You literally divide the numerator by the denominator. Now, when you do that, you're going to get one of two things happen. You're either going to get a finite decimal and you stop right there and you end, or you might find yourself in this forever repeating pattern where the decimal just continues to go on and go on and go on, and it seems like the long division will never end. Well, that's what we call a repeating decimal. We'll show you how to handle both of these situations. All right, so let's take a look at our first example. Let's say we have 12 fifths, and we'd like to write this as a decimal as opposed to a fraction. What we're going to do is we'll literally take 12 and we'll divide it by 5 using long division. So 5 goes into 12 a total of 2 times. 2 times 5 is 10. We subtract, leaves a remainder of 2, but we're not going to stop there at the remainder. 12 could be written as 12.0, right? And so we're going to include a decimal place here so that we get an additional unit, 0 after the decimal place. We'll bring the 0 down, and then we'll keep going. We'll say, what times 5 gets you close to 20? Well, 4 times 5 does. So we'll put a 4. 5 times 4 is 20. We'll subtract, and you'll keep doing this. Here we only had to do 2 steps. You might have to do 5 steps, but you're going to do as many steps as it takes to get to a remainder of 0. Then you can stop. So now, what's our final answer? Well, here we had 12.0. We're going to carry this decimal up to the quotient. So 12 divided by 5, or 12 fifths, is the same as the decimal 2.4. So you include as many zeros after the decimal place as you need. You do long division, and then you place your decimal place appropriately. All right, now, as I said earlier, sometimes you do this process and it never ends. And it seems like you think you might be doing something incorrect, or really you're totally fine. It's just the nature of the problem. If the decimal seems to keep repeating for forever, we're going to use a shorthand notation. You can call it the bar notation. It uses a bar to indicate that the decimal is repeating. Let's look at a light example, and then I'll do a more substantial example. 1/3, and I'll spare you the algebra, could be written as 0.3333333, and it would continue on for forever. As long as you kept writing threes, it would continue on. So when do we stop? Well, to equal 1/3, you can't stop. And so to express this repeated pattern of 3, we're going to write 0.3, and then we're going to put a bar over whatever continues to repeat. Now, if you had an example where more than one digit repeats, that's totally fine as well. If you had, for example, 0.182, etc., then where do you put your bar in this example? You would put 0.182 and put the bar over the 1, the 8, and the 2, which indicates to the reader that's what's continuing to repeat over and over again. So use this bar notation, and it'll really help make you not have to write quite so much.